Hello everyone! Before you begin working in the organic chemistry laboratory this semester, it is important for you to become familiar with the policies and rules set forth by the chemistry department. Additionally, it is to your benefit to be aware of the changes made to the labs themselves, whether the physical facilities or how the experiments will be conducted in light of concerns over COVID-19. This presentation will serve as a review of the policies, rules, and conduct in the lab for this coming term. Here is a brief overview of this presentation. We will begin with a safety review, which will include a few comments about general safety, as well as a review of the policies and rule sheet issued by the chemistry department. Although the safety rules are not clearly grouped on the sheet, they will fall into 5 basic categories: pre-lab basics, hazard avoidance, proper equipment, good lab practices, and incident response. Upon reviewing the safety information, we will then go over a few changes that have been made to the labs to help you become more familiar with these changes before you walk into the lab and begin your work. Before discussing the departmental policies and rules for working in the laboratory, it is important to discuss a couple general safety tips that will not only serve you well in this class, but in other classes and when working in a laboratory in general as well. The first important point to know is that maintaining a safe working environment is both a group and an individual responsibility. In the organic chemistry lab, each student will be working on their own experiment, but sharing the lab space with other students in different ways. For example, a student will be sharing a work bay with one other student, while also sharing the general lab space with 7 other students. The other half of the class will be working in the adjacent class lab next door to ensure adequate social distancing during their experimental work. All organic chemistry lab classes will share this lab space in the same way by working in the lab bi-weekly, alternating when they are working in the lab. Organizing labs in this manner poses an extra challenge to instructors, as they now have to supervise experiments in 2 rooms at the same time. Unfortunately, they only have 1 set of eyes and 1 set of ears, both of which travel with them as they walk through the lab to supervise their students. If an incident occurs in one lab while the instructor is present in the lab next door, it is possible that they will be unaware of the incident that has taken place. This is where additional situational awareness will be beneficial for everyone working in the lab. If students are more aware of proper working conditions, they can help each other avoid hazards, and if an incident occurs, those working near the area of the incident can aid in the response by calling it to the instructor's attention. To address the safety policies first, there are 2 major themes within them: medical concerns and permissions. To address the medical concerns first, any student with medical concerns should seek the advice of a physician before attending labs. While your lab instructor holds a doctorate degree, it is a doctor of philosophy, not a medical doctorate. They will not opine on medical matters. However, if you bring your concerns to your instructor, they should be able to help you gather the necessary information that you can take to a trained medical doctor for their opinion prior to attending lab. Additionally, no student shall work in the laboratory when under the influence of substances, whether alcohol or drugs, including prescription, over-the-counter, or recreational drugs, that would impair the laboratory activities and create an unsafe environment. Just as you would not come to lab drunk, you should not come to lab while high, or under the influence of any medication. The important thing to remember is that this is a class laboratory. This means you are learning how to work in a chemistry laboratory. While experiments are selected with safety in mind, you know your health better than your instructor ever will, so it's wise for you to assess whether or not you'll be able to work effectively in the lab before attempting any experiment. While working in the lab, there are a few things you cannot do. First, no student shall work in a laboratory outside of regularly scheduled classes without permission from their instructor. The class labs are locked when not in use, and only in the case of any makeup work will you be allowed inside of the lab outside of your scheduled class time. This will prevent any makeup work from interfering with other classes that share the lab space. Similarly, no student shall work in a laboratory alone without permission. Typically, special permission to use lab space more independently is given to research students, who have a bit more training than other undergraduates. Guests are also not permitted in the laboratory. This is to protect those working in the lab, as well as said guests, who may or may not have any chemical training. Lastly, do not perform unauthorized experiments in the lab. While learning how to handle chemicals, going off script is an easy way to have things get a bit more out of hand. The bottom line between these 4 items is that time and resources are set aside only for registered students in a given class. As students, you are here to learn how to safely carry out common laboratory techniques and handle chemicals in a supervised setting. Since you learn by doing here, the best way to learn is to learn how to do things as indicated by your given procedure. Next is to discuss the safety rules part of the safety sheet. The first 3 items cover what I call pre-lab basics. In other words, these are things you can do before coming to class, although they may not be a part of your pre-lab tasks or assignments. Even though the instructor will discuss potential hazards before the beginning of the experiment, you should familiarize yourself with the experiment, the chemicals, the procedure, and the equipment before class. Material safety data sheets of chemicals used in the lab can be found at msdsonline.com. The username for the university is NMU-MSDS in all lowercase letters. The password is NMU, all in capital letters, period, MSDS, all in lowercase letters, 20. Similar safety information can be found in the Safety and Hazards section of a chemicals entry in the PubChem database. Alternatively, and depending on the course, your instructor may have a summary of key safety information within the experiment reading. Next, clothing must fully cover your torso, legs, feet, and upper arms. Clothing can serve as protective equipment in that it can provide a barrier between you and the chemicals with which you work. In the case of a spill, clothing can help slow the spread of chemicals to your body, allowing you a little more time to react to a spill and help you remove chemical contamination. Lastly, before starting your lab, keep benches and aisles free from clutter. Backpacks, coats, and personal items must be put away. This is why you enter near the coat rack area of the lab. You can quickly put your belongings there, away from most chemicals, and nobody will have to worry about tripping over bags and coats. The next 3 safety rules will help you avoid hazards while working in the lab. First, there will be no food or beverage allowed in the laboratory, including chewing gum. Food can absorb trace chemicals in the lab environment, so leaving food and drinks outside of the class lab is a wise idea to minimize your exposure to chemicals. If you get a bit hungry or thirsty during class, you can remove your gloves and step outside briefly to have a little bit to eat and drink before coming back in and returning to your work. Next, long hair needs to be confined when working in the laboratory. Long hair can end up in a variety of places, such as in equipment with moving parts, inside a beaker or flask containing chemicals, or even against an active hot plate, causing the hair to be singed. Finally, wear approved safety goggles at all times and gloves as needed. Your eyes are 2 of the most important organs to protect because working in the laboratory is a highly visual experience. If you cannot see what's going on, you cannot make the proper observations to understand your work. Even worse, you may mix the wrong chemicals together if you are not able to read the label on the bottle. In addition, for this semester, face masks or other face coverings are required in addition to goggles. Between the 2 items, just about your entire face should be covered by protective equipment while in the lab. Please note that some students may wear a face covering other than a mask if it has been approved by Disability Services. In those cases, the instructor has already been made aware of the accommodations required for those students. The next 3 rules concern proper lab equipment outside of personal protective equipment. First, do not use broken or chipped glassware or damaged equipment. Broken glassware is never okay, but chipped glassware can be more of a gray area. For example, a small chip on the rim of a beaker could bring a small cutting hazard with it, but may otherwise not affect the beaker's function. When in doubt, ask your instructor for their opinion. Cracked glassware, however, is never acceptable. When checking in your lab drawer, be sure to inspect the quality of your glassware. Once you sign the check-in sheet, you are responsible for the glassware, so if you miss any cracked glassware and then sign the sheet, you could be held responsible for it. On the other hand, if you catch cracked glassware before signing the sheet, you'll be given a replacement free of charge. Make sure to dispose of any broken glass in the glass disposal boxes near the chalkboards in each lab. All glass needs to be disposed in this designated box, otherwise it could provide hazards to other students, instructors, and even custodians who operate in the lab. Lastly, use of cell phones and laptops are only allowed upon the approval of your lab instructor. You'll rarely need a cell phone in class because you should have a basic scientific calculator with you, and each lab is equipped with a clock. Resist the temptation to tap and swipe your cell phone with gloves on, because you may transfer any chemical residues from the gloves to your cell phone. Also, you'll be less distracted if you're not constantly checking your cell phone in class, meaning you'll likely finish your experiment a little bit faster. If you need to use your cell phone during class, get your instructor's permission first. They are likely to say yes to any reasonable request anyway. The next 5 safety rules are considered good general lab practices for an organic chemistry laboratory. Never use an open flame to heat organic solvents. A very common hazard of organic solvents is that they are flammable and therefore should be gently heated without the use of a flame. However, care must still be taken even when heating organic solvents with a hot plate, because aggressive heating of an organic solvent can still cause it to catch on fire. Never leave an experiment unattended. If anything happens to your work, someone in the lab needs to be ready to respond, whether it's handling a hazard or even just making an observation. If you need to leave the class lab for a moment, see if your baymate can help by keeping a watchful eye on your work while you're gone. Your instructor may also help, but remember that they can't be tied up for too long because they have to supervise activity in two lab rooms during class. Next, note the odors of chemicals only when told to do so, and only waft the fumes. Fume hoods are designed to handle any vapors given off by chemicals and reactions. If you have to take a container of chemicals out of the fume hood, make sure to cover it to minimize the exposure to any vapors. If you are not careful, some chemical vapors can hit your nose pretty hard, especially if they are acids. Continuing on with good lab practices, dispose of any chemicals as directed by your lab instructor. Safe disposal of chemicals helps eliminate hazards. For example, if you mix 2 types of waste, they could react and give off heat or produce gases, both of which would be bad for a closed container. Always look before you pour. Make sure you have the right container, check that there's adequate room in the container, and then lift the lid on the funnel before pouring your waste into the container. If the level of the liquid inside the waste container is up to the shoulders of the bottle where it begins to narrow toward the neck, let your instructor know so that they can swap in a new waste container. Finally, before leaving the lab, make sure to wash or disinfect your hands. You never know what sorts of residues may be on your hand, even if you wear gloves. While gloves do protect your hands, they are not infallible. They minimize exposure to chemicals, but do not completely eliminate exposure. This is because some chemicals can still pass through the material of the glove, so washing and/or disinfecting your hands after lab can help remove any residues or contamination that made it through the material of the glove. The last three rules on the policies and rule sheet concern how to respond to incidents. In the case of spills, leaks, injury, fire, or any other unsafe situation, notify the instructor immediately. This is particularly important this semester, as the instructor may be in the adjacent lab at the time an incident occurs. Should this happen, you may need to rely on students working nearby to get the attention of your instructor. Next, report all spills or broken glass immediately. Clean it up as instructed by the lab instructor. Labs are equipped with a broom and dustpan for cleaning up broken glass, so do not attempt to pick up broken glass with your hand. If there's a chemical spill, your instructor will need to know what you spilled in order to know how to clean it up. If you spill just water and not an aqueous solution of a chemical, you can easily clean the mess up with a sponge. However, once chemicals other than water are involved, the cleanup protocols depend on the chemicals spilled. If you get a chemical in your eyes, a burn, or a cut, flood the injured area with cold water for 15 to 20 minutes. Report any injury to your instructor. It's important to use cold water to flush a wound because the lower temperature of the water means the chemical will react more slowly with any affected bodily tissues. Sometimes, the cold water can be as cold as about 50 degrees Fahrenheit. In the case of your eyes being exposed to chemicals, another person may have to help you hold your eyes open to effectively flush out any chemicals. Now that you have reviewed the departmental safety policies and rules sheet, be sure to add your name, signature, and the date to the Department of Chemistry safety notes and department policies signature sheet that will be present in the lab during check-in. Be sure to fill it out using your own writing implement while wearing gloves. The sheet is an acknowledgement that you have received and reviewed the safety policies and rules of the department and that you understand all aspects of the stated policies and rules. To protect your ID number, leave the NMU ID box in the third column blank. Your instructor can fill this in after check-in has been completed by the whole class. With all the changes made to the physical lab space this semester in response to public health and safety guidelines regarding COVID-19, the following slides will help you become a little more familiar with the lab before you arrive for your check-in time. In a typical semester, most students tend to disregard the signs that are posted throughout the lab because they've always been there, and they're just a part of the lab environment. This semester, it is important to pay more attention to the signs posted throughout the labs as they will help you maintain social distancing while working safely in the lab. The signs will indicate entrances, exits, workspaces, hand washing areas, and waste disposal areas. By taking note of these areas before getting too involved in your work, you can begin to figure out how you'll move about the lab effectively. The doors to and from the labs will be marked with signs to indicate where to enter and exit. Exit-only doors, like the one shown on the right, will likely be outside locked anyway. This means you won't be able to open the door from the outside, but will be able to open the door from the inside in order to exit. Also, the colored paper on which the signs are printed are not an accident. A quick rhyme to help you remember which doors you can access is green means go and pink means no. Regardless of the exact lab room in which you'll work, you'll always enter the lab nearest the coat rack area, which is located by the high-numbered workspaces like 6, 7, and 8. This way, if you're sufficiently ready and already have your notebook out of your backpack, you can enter the lab, set your backpack down by the coat rack, hang up your coat, go to your workspace, and begin your planned work. Exit doors are always closest to the safety shower and fire extinguisher area. Notice the green-colored exit-only sign on the back of this door, and remember, green means go. In the case of an emergency, however, All doors will be exit doors in order to expedite departure from the lab should it ever need to be evacuated. In the past 3 or 4 slides, you may have seen some signs with numbers on them. These are the workspaces in the lab that you will use for your experiments. Each student will work in one fume hood, and no more than 2 students will occupy a bay. The workspaces are numbered to help you locate all of your working area. In addition to the fume hoods being numbered, you'll see numbers throughout the lab to indicate sinks and balances that you can work with as well. When in doubt, look for your number to find your workspace, balance, and sink. Not every workspace has a designated hand washing area because some sinks are too inconveniently set back for easy hand washing. If you cannot easily reach the sinks in the center of the lab, you may wash your hands at the sinks labeled with the blue hand washing icon. However, be sure to check that nobody else is at that sink at that time. For convenience, there is a hand washing sink located near the exit in each lab. If a chemical gets into your eyes, you'll need to use the eye wash to flush it out. The eye washes can be found at the sink for stations 1 and 2, as well as at the sink for stations 7 and 8. In the picture on the right, the eye wash is circled in yellow. The eye wash is attached to a hose that can pull out from the bench. To use an eye wash, flip down the orange covers and squeeze the handle just below the branch in the hose to deliver water. You will need outside help with this, as someone will likely have to hold your eyes open. You'll want to reflexively close your eyes when they're in the streams of water, but doing that will not help flush your eyes. In the corner of the lab by the exit door, you'll find a handicap accessible eye wash, which is just to the left of the yellow circle. The safety shower, the handle of which is circled in yellow, and the fire extinguisher, which is just to the right of the yellow circle. Because this corner of the room is used for safety equipment, no personal belongings can be stored here to allow unhindered access to this equipment. To activate this particular eye wash, pull the top of the eye wash down so it swings out. To start the safety shower, move the lever, circled in yellow, downward. Waste disposal areas are near the front of the labs by the chalkboard. The glass waste container is a blue and white cardboard box with a plastic liner and is usually located by the chalkboard. It is usually placed as far away from the class waste fume hood as possible to prevent students from congregating in the waste disposal area. This box is used for the disposal of broken glass and used pipettes and/or capillary tubes. The chemical waste fume hood is also near the front of the labs by the chalkboard. Like any other work area in the lab, it too has its own sign, which reads Class Waste. This fume hood is where you'll dispose most of your chemical waste, with liquid organic waste being closest to the chalkboard, solid waste and recovered compounds in the middle of the fume hood, and aqueous waste closest to the lab entrance. You may even see the words organic, solids, and aqueous written on the bottom of the sash to designate the different waste areas within the fume hood. Depending on the amount of containers and the lab being performed, there may also be another set of reagents in this fume hood, so be sure to read all bottles carefully before working with them. You don't want to pour your waste into a reagent bottle with which other students may have yet to work. To prevent lines at sinks for cleaning glassware, each workspace has been given a small plastic tub for cleaning glassware. You can use a bit of soap from your sink area and then use the water supply from the back of your workspace to add water to your tub. Make sure the tub is no more than 1/3 full with water to make transporting the tub to the sink much easier. Use only soap and water in your tubs. Some plastics will dissolve in organic solvents. Methylene chloride and chloroform are usually pretty good at dissolving plastics. While acetone is plastic safe, do not use it in your tub. When finished washing any glassware at your station, you'll dispose of the water in your tub by pouring the contents into your numbered sink. By not filling the tub as much, it will be easier to carry and bring to the sink for disposal. Carrying your tub to the numbered sinks is also a lot easier than trying to pour your tub water into the small cup sinks in the back of your fume hood. Before finishing for the day, make sure your workspace is clean before you leave. Depending on your instructor, this may be a part of the lab day before you leave anyway. If you find a mess at your workspace at the start of a lab, let your instructor know, as they may know what the mess could be based on the master lab schedule and may be able to advise you on how to properly clean it up. If you wouldn't want to clean up a mess at the start of your lab, make sure you leave your workspace in good order before you go so that you don't do that to someone else. The labs currently use the blue-colored nitrile gloves. These gloves are safe to dispose of into the trash cans by the work bays. Once the labs start using the green nitrile gloves, be sure to dispose of them into the recycling bin before leaving the lab. You should not be touching doorknobs with gloves on anyway, but the recycling bin is located by the exit as a reminder. However, it must be stressed that only green nitrile gloves are to be recycled. Your lab instructor will remind you of this policy once the green nitrile gloves are in circulation within the labs. If you ever have any questions about how to safely work in the laboratory or how to handle certain situations, never hesitate to ask your lab instructor or the lab coordinator for your course. This concludes the Safety Review and Lab Familiarization presentation. Good luck to you this semester.
Hello, and welcome to the Organic Chemistry Labs. Our topic for today is safety. The purpose of this film is to teach some organic laboratory safety practices and to illustrate why these practices are important. We will also show you what to do if an accident or chemical spill does occur. Of particular importance in the organic chemistry labs are eye protection and proper apparel, eye washes and showers, good glassware handling practices, proper handling of thermometers, not having food or drink in the labs, waste chemical disposal, fire hazards. Whenever anybody in the room is performing an experiment, the eye protection required is goggles. Our teaching assistant today is Randy, and he is wearing an acceptable style of goggles. Melinda is a student in organic chemistry, and she is also wearing an acceptable style of goggles.
Dave, that's not a proper dress for lab.
What's wrong with this?
Well, first off, sandals are not going to protect your feet from chemical spills or broken glassware on the ground, and you should wear long pants to protect your legs from any chemical spills from the bench. Also, do you have a pair of Playtex gloves with you today?
No, I don't.
Okay, you ought to bring in a pair of gloves so that your hands are protected from chemicals on the bench. Also, run down to the stockroom and get yourself a lab coat, and make sure you wear your goggles when you come back into lab, okay?
I haven't got any goggles with me.
Okay. Borrow this pair for now and get a pair later.
Thanks.
Many times students feel that they only have to wear goggles if they're performing an experiment themselves, but this is not true. Even if you are not performing an experiment, but someone else in the lab is, you must have your goggles on. It's a good thing that these students had their goggles on. Note the location of the handheld safety wash in your lab. There are no safety showers in the labs or in the hallways. If necessary, the student would remove clothing to wash his or her skin better. This is no time for modesty. Now our students will demonstrate the proper use of eye washes.
What do you think it is? What did you get in your
I don't
eye?
know. Maybe hydrochloric acid.
Dr. Smith! Dr. Smith! You gotta wash it for 15 minutes. Keep your eyes open.
What did he get in his eye?
I don't know. I think maybe some HCl. I'm not sure.
Okay, Dave, keep your eyes under there. Keep them open. Do that for about 15 minutes and then go over to Wardenberg. I'm going to talk to the lab coordinator about this, and I'll be right over after you, okay?
Be sure to rotate your eyes.
I'm trying.
We strongly recommend that students do not wear contact lenses in the lab for two reasons. For one, they interfere with proper washing of the eyes in the case of chemicals splashed in the eye. Secondly, soft lenses can absorb chemical vapors from the air in the labs, causing irritation or become damaged or even fuse to the eye. The proper handling of glassware is critical to the prevention of both chemical spills and glassware breakage. Whenever possible, clamp down your glassware to hold it in place and prevent it from breaking. Note how the student clamps the flask securely to the ring stand before attaching the vacuum tubing. Note how sturdy Melinda's glassware setup is.
Oh, Dave, better wash your hands off. Dr. Smith?
Dave, what have you done now?
I spilled something.
Okay, wash your hands for about 15 minutes then, and I'll go talk to the lab coordinator and fill out an accident report form with Wardenberg. Do you know what you spilled on yourself?
Nah, I've never.
Okay, well, you're doing the aldol condensation, so it's probably sodium hydroxide, ethanol, and water. I'll get a spill pill and clean that up. And Dave, next time wear your gloves.
Okay.
Randy is now demonstrating one method for dealing with a chemical spill. If the spill had been a toxic, volatile, or flammable substance, or if the spill had been very large, he would have required the class to evacuate the lab immediately and pulled the alarm to announce that the building should be evacuated. The alarm is located in the hallway outside the organic labs. In the past, accidents and chemical spills have occurred due to improper clamping of glassware for a distillation, a procedure with which you will become all too familiar. Melinda is setting up a distillation apparatus properly. Working in her hood to prevent solvent from escaping into the room during the distillation, Melinda first clamps the round bottom flask securely to the ring stand. Then she places a ring and a heating mantle under the flask. She attaches a Y adapter to the top of the flask. She then secures the condenser with a clamp to a ring stand and with a plastic clip to the Y adapter. Finally, she connects the vacuum adapter to the condenser with a plastic clip.
Dr. Smith?
What have you done now, Dave?
I cut myself. I don't know.
Okay, that's good, Melinda. Apply direct pressure and you can raise his hand up a little bit and that'll help. Dave, where the heck are your gloves?
I just lose them all the time. They're horrible.
Okay, let's go see the lab coordinator about this. Melinda, could you give him a hand cleaning up and make sure you put the glass in the glass waste container over there, okay?
Sure.
Thank you. Dave, what are you doing? Come on. Somebody's going to get cut on that just as you were. Now, look, there's a glass container over there. You put the broken glassware in the glass container, not in the sink, okay? Put your gloves on first before you go doing that.
Okay.
Broken thermometers are a particular hazard in the lab. As well as the usual hazards of broken glass, they pose the dangers of mercury exposure. The tips of thermometers are particularly fragile. Always handle thermometers with particular care and never use a thermometer as a stirring rod. If you break a thermometer, immediately inform your teaching assistant.
Thermometer, Randy.
Okay, hold on a minute, Dave. Let me get you a mercury sponge. Okay. I want you to use this sponge to clean up the mercury all over here. Use the gritty side after you've wet it down to sop it up the mercury. How did you break this thermometer anyway?
Stirring my mixture.
You should never, ever stir a mixture with a thermometer. You should use a glass stir rod. They're in your drawer, okay? Don't let me catch you doing that again.
Okay.
The chemistry laboratory is not the place for radios, Walkman, food, or drink. Dave has done it again. Never bring food or drink into the lab. At the end of your experiment, you must place waste chemicals in the proper waste containers. Pay close attention to the labels on the waste containers. Your lab manual states where to place waste, and there is a reason for this. If you put a waste chemical in the wrong container, it can react and cause an explosion. If you put a waste chemical in the wrong container, it can react and cause an explosion.
Where's this go?
Dr. Smith, we've got a problem here.
Fires in the organic lab can be a real danger. Unlike the general chemistry laboratory, the organic lab contains many chemicals that you will use which are flammable. Of course, smoking is not allowed in the labs. Much of the fire danger has been eliminated by the choice of heat source in the experiments. The open flames of Bunsen burners are rarely used anymore in the organic labs. Instead, we use steam baths, which are attached to the laboratory steam lines, and electrically heated mantles, as Randy is demonstrating.
Since steam baths here only reach temperatures of 100 degrees Celsius, we use heating mantles to achieve higher temperatures and boil solvents that require a higher temperature. Heating mantles are connected directly to Variacs, which is this device here. The Variac is a variable transformer and is controlled through this knob here. Whatever you do, do not connect the heating mantle directly into the wall. That will cause it to short out and catch fire. Also, make sure that you have the Variac set on 0 before you turn it on. If you do not do this, you may be surprised when the heating mantle heats up very rapidly. Although heating mantles do not require an open flame like a Bunsen burner does, they can still cause solvent fires if hot solvent splashes onto them. In case of a solvent fire, you need to know what to do. There are two types of fire extinguishers located in the front and the back of this lab. The first one is a CO2 fire extinguisher used to extinguish dry and chemical fires. CO2 fire extinguisher has a large cone for a nozzle. To use this fire extinguisher, you pull the clip, aim the nozzle at the base of the fire, and then pull the trigger. The second type of fire extinguisher is a dry chemical extinguisher. These extinguishers are filled with a dry chemical and can be used to extinguish chemical fires and dry fires as well as electrical fires. We're not going to use this extinguisher because it's filled with the dry chemical that makes a mess when we pull the trigger. However, these extinguishers should only be used if you cannot find the CO2 extinguisher. You can tell the difference by noting the two different type of nozzles.
Ooh, somebody get a fire extinguisher. Sound the alarm. Oh, never mind. I got it out.
Use of a fire extinguisher can knock everything over and spread the flames. In the case of any fire, Even if someone is trying to put it out, everyone must exit the lab and building immediately. Someone must activate the alarm in the hallway to evacuate the building. The fire department should be called at 911. If the fire is put out by the student, the fire department can always be called back to cancel.
Everyone, listen up, please. I want you to leave the building right now. We've got an out-of-control fire next door. So file out, single file, and follow the exit signs. Don't panic, okay?
You must keep your personal belongings off the floor. In the case of a fire alarm, you must exit the lab and the building immediately. Don't wait to finish your experiment, though you can quickly switch off your heating mantle or Bunsen burner. I hope you enjoyed our presentation and have learned enough about laboratory safety to have a safe year in organic chemistry. Thanks to our student actors.